Flight lock in.
23.
SRM TDC blowdown.
15.
Rofi ignition.
10.
T-minus
Fisher
10, 9, 8, 7, 6, 5, 4, 3, 2. We have ignition of the RS-68 engine, and we have liftoff of the United Launch Alliance Delta IV rocket carrying the 9th GPS-2F satellite for the United States Air Force. The Global Positioning System provides worldwide positioning, navigation, and timing service for military and civilian users.
20 seconds into the flight. Good engine control on the first stage. Now passing 30 seconds. Altitude now 1.5 nautical miles. Velocity 1,659 feet per second. Downrange distance 3.8 nautical miles. 40 seconds in. Chamber pressure beginning to decrease in the...
You are hearing the voice of Steve Agate providing launch vehicle ascent data.
50 seconds. Mach 1. Vehicle going transonic. Coming up on the 1 minute mark. Mark, 1 minute, 1 second, max Q, maximum dynamic pressure in the vehicle. $70 seconds in. We have about 20 seconds left in the solid rocket motors before they burn out as we pass 11.5 nautical miles. Standing by for burnout. We have burnout, standing by for separation. We have separation, good separation of the solid rocket motors. 1 minute, 50 seconds in. Now T plus 1 minute, 57 seconds into the flight. The Delta IV rocket now only weighs 1/2 as much as it did at launch, burning propellant at 1,849 pounds per second. 2 minutes, 7 seconds in. Altitude now passing 25.6 nautical miles, velocity 5,724 feet per second, downrange distance 35.5 nautical miles. 2 minutes, 20 seconds in. Chamber pressure holding exactly as we'd like it to be in the first stage. Very little engine movement. 2 minutes, 37 seconds in. Now passing 35 nautical miles, velocity 7,655 feet per second, downrange distance 61.8 nautical miles. 2 minutes, 50 seconds in. About 1 minute and 10 seconds remaining in first stage flight as we're coming up on the 3 minute mark. 3 minutes into the flight. Altitude now passing 42.7 nautical miles, velocity 9,592 feet per second, downrange distance 91.13 nautical miles. 3 minutes, 12 seconds in. As we continue to accelerate, we're standing by for the area of our maximum skin temperature on our fairing about 2 seconds from now. Now in that area. 3 minutes, 30 seconds. About a half a minute remains now until we go to the partial thrust command on the first stage. 3 minutes, 40 seconds in. Still looking good. We'll be going to the partial thrust command about 15 seconds from now. Standing by for partial thrust, about 57% of the full thrust mode. And we have the partial thrust command. Standing by for main engine cutoff. We have main engine cutoff. Standing by for stage separation. And we have stage separation. NEDS deploy is in work. Nozzle is going into its position. Standing by for igniter spark. And we have igniter spark. And we have ignition. Ignition on the second stage. Second stage chamber pressure is beginning to rise. Standing by for fairing separation. And we have payload fairing separation. 4 minutes, 52 seconds into the flight. Chamber pressure is good on the second stage, right where we want it to be.
This is Delta Mission Control at L plus 5 minutes, 2 seconds. We've just heard Steve Agid report the successful execution of the events comprising the early portion of today's mission, and all systems continue to operate nominally. The Delta IV second stage and GPS-2F satellite are traveling over the Atlantic Ocean in a northeasterly direction and up the east coast of the United States. The mission is now in the first of 2 planned RL-10 second stage engine burns, and all systems continue to operate nominally. This burn will last approximately 11 minutes. I'm joined now by Lieutenant Zach Peters. Hi, Lieutenant. Thanks for joining me.
Thanks, Courtney. I'm excited to be here to witness this spectacular launch.
To start off, can you tell us the current status of the GPS-2F program?
Sure, the government has purchased 12 GPS-2F satellites, 4 of which have been successfully launched last year. This puts us at 9 GPS-2F satellites on orbit and meeting all mission requirements. There are 3 more satellites in the pipeline. One is in storage, one is in launch processing here at the Cape, one is in production testing. That final GPS-2F satellite will be complete this year, with a launch scheduled to occur in early 2016.
Okay, well then can you tell us about the GPS constellation?
The GPS constellation remains healthy, stable, and robust, with 30 operational satellites on orbit. The legacy GPS satellites have remained operational well past their design lives. Today we have 3 of the original GPS Block 2A satellites still operating and providing reliable positioning, navigation, and timing services. 15 of the 19 GPS-2R and 2RM satellites are beyond their 7.5-year design life. The need for the GPS-2F capability is vital to update the GPS constellation and maintain a high level of accuracy required by the GPS system. We are launching the new GPS-2F satellites to increase GPS signal capabilities, increase user accuracy with improved space atomic clocks, and reduce overall constellation sustainment risk.
So how does GPS work anyway?
GPS utilizes a series of radio signals broadcast by a fleet of at least 24 satellites on orbit around the Earth. Currently, the GPS constellation has 30 active satellites. The GPS is a space-based radio positioning system comprised of at least 24 satellites. These satellites, along with the associated hardware, software, systems engineering, operations, and sustainment, are operated by the United States Air Force and provide the military and civilian communities positioning, navigation, and timing services free of charge. There are a total of 6 GPS orbital planes, each with at least 4 satellites. The GPS satellites are approximately 20,200 kilometers from the surface of the Earth in a medium Earth orbit, which is nearly circular and inclined 50 degrees. GPS is based on the fundamental concepts of time, distance, and the speed of radio waves, which is approximately that of the speed of light. The GPS signal is actually a radio wave that is emitted from each satellite and is basically the satellite's position and time. A GPS receiver on the ground receives these signals, and based on the time the signals are transmitted and received, it can calculate the distance from itself to those satellites and use that to formulate a positioning solution. It takes a minimum of 4 GPS satellites to determine a position on the Earth. This position, combined with the geographical map or grid in the receiver, allows a user to discern the location on Earth.
So changing gears a bit, Lieutenant Peters, why did you decide to join the Air Force?
I was originally attracted to the Air Force because of its professionalism and higher calling. It also helped that the Air Force paid for my college education at the Air Force Academy. I'd always had a lot of respect for the military, and from growing up overseas, I realized a lot of other countries had that same respect. Therefore, I was interested in attending one of the service academies after high school. I ended up choosing the Air Force Academy because of its emphasis on technology and personal development. When you attend a service academy, you have a minimum commitment of 5 years after graduation. So here I am.
Will you provide some background on how you got this position?
Yeah, actually at the Air Force Academy, I found out I was colorblind and I couldn't have any rated positions. So I ended up choosing to be a financial officer because I thought that with the looming budget cuts, it would make it more challenging and rewarding. I spent 2 years in Germany managing the budget for a U.S. tenant unit base on a NATO military base before I came to the Space and Missile Centers in L.A. I'm currently working as an earned value management and cost analyst.